Okay, hello everyone. This is going to be a video that talks primarily about geometry and some other related things that we can do with this. So a little bit about the kind of the default orientation of this workspace that we have here in STAR-CCM Plus, and the nomenclature I use for this. So we have sort of the simulation tree on the left. This is where you'll access different parts of the simulation. Um, Whether it's geometry parts that you make, a block, a cylinder, a sphere, etc. Whether it's a plot of results, whether it's modifying boundaries, etc. Pretty much everything is accessed via this tree. You find it here. It is referential. That is, things you'll have on. Let me come up with a good example here. You'll have different levels of things. Like you'll have a part, and under the part you can have different other things. Boundaries will have different types of properties, etc. Don't worry about it too much at the moment. Today I mostly want to focus on geometry, but we will need to talk about also the properties. This window down here, bottom left, this contains a handy reference where you can edit a lot of things about most things in the simulation. Today we're going to be using it for geometry specifically, but it's used to edit properties of pretty much anything. It's also a handy at-a-glance reference for what those properties are. The output is over here. Output or console, I'll sometimes use different vocabulary for it, is out here over on the right. This kind of just tells you what the simulation is doing at the moment. Right now, this is just part of the text it spits out when you open a new simulation, as it checks for licensing and whatnot. It's currently blank, but this last major area that takes up the bulk of the workspace actually is for scenes. So this is for three-dimensional representations of the simulation that you're currently working with. And if there's something here, you can generally use it to spin around and kind of look around your simulation, get an idea of what's going on, and see it as a three-dimensional representation. So when we talk about geometry, it all takes place in this geometry folder at the top left. Pretty obviously, geometry takes place in the geometry folder. This has a couple of different folders in it. It has 3D CAD models, it has parts, and it has contacts. So parts are, well, let's start with 3D CAD models. So if we want to do something more complex geometrically inside of STAR-CCM Plus, it'll generally be via a 3D CAD model. So you saw that I hit right click and I hit new. Hold on a second. There we go. Now it should be easier to see what I'm doing. And it opens up a new window or a new tab up here. So we were in simulation. Now we're in 3D CAD. And it shows a coordinate system. We can click and drag inside of this window that it opened up in the scenes and see that we have a coordinate system. Typical XYZ right-hand rule coordinate system. There's an origin for the entire thing. And we can see there's a couple other folders. So what can we do with this? Well, we can do a lot of different things with this. But mostly we can do various things that you'd find in most CAD softwares. So you generally need to start by creating a sketch to define some two-dimensional geometry that you can use and turn into three-dimensional geometry. So I'm going to start, just as a brief example, And we won't go into this in a huge amount of detail because it does work very similar to most other CAD applications, and you're probably familiar with at least one that works like this from previous classes. We're going to hit create sketch on the XY plane, and we're going to get a sketch. If you want to rotate, and you can't see what key I'm pressing, obviously. If you want to rotate this scene like this, you can hold Control, click and drag, and it'll rotate without rotating in 3 dimensions. It'll only rotate about your current view axis. So that can be handy to get things a little bit nicely aligned with the screen. When you're sketching, you can create points. Oh, you can create 1 point at a time. Some of these may have hotkeys. I don't use this very often, so I don't remember any of them. But you can create points. You can create lines, which are obviously collections of points that are connected to each other. Rectangle, a 3-corner rectangle, which makes it easy to set it at off orthogonal orientations. Circle, obviously. Circular arc. 3-point arc. So more or less just a different way of defining a circular arc with that one. Ellipsoid. So major axis, semi-major axis, and origin. And the more complex one, which is a spline. You can do really fancy things with splines, but they're kind of a pain in the neck to properly define. But they are handy to make organic curves and shapes like that. Now, obviously, that's a lot of curves. We don't really need that many of them. Let's see here. Where? Go ahead and delete these. Where the heck did it go? Sorry, 1 second. I'm trying to remember where the button I need is. Actually, tell you what. The simple thing to do is just hit cancel and not OK, and it didn't actually create that sketch. So all that random geometry that we didn't really want no longer exists. But if we go into the sketch, we can create something. Let's see if we can make some sort of interpretation of a probably pretty shoddy airfoil. But we'll see what we can do. So we're going to do a center point arc. So we put the center at the origin. Okay, that's interesting. So that's more going to look like an ice cream cone sort of thing. So these two, we can set constraints by selecting any 2 things, right-clicking, and saying those are tangent now. We can also, I believe, create construction geometry here. So if we make another line, we can select it, right-click, and say set as construction, and that means it doesn't actually represent anything. but we can use it to apply constraints. So this isn't really much of an airfoil. It looks more like the cross section of an aileron or horizontal stabilizer or whatever. But it'll do. We can also dimension things. We can say that we want this to be a radius of, that's about half an inch. Let's do 5 centimeters. And then we can apply a length dimension here. Let's do half a meter. Or better yet, let's tell it 2 feet just to demonstrate that we can mix and match dimensions here. So this was dimensioned at 2 feet. This was dimensioned at 0.05 meters. If you don't give it a dimension, it'll assume SI units. But most things are done with a right-click menu. In various ways within the 3D CAD tool or the basic sketch utilities on that'll or the toolbar buttons that show up on the left. So we have a sketch now, sketch 1. We can again do things to this by right-clicking on it. We can rename it, we can hide it, we can show it, and we can extrude it or revolve it. If we want to extrude, we can choose what type. We can make it a sheet body, a solid body. Again, I'm not going to belabor this too much, but more or less you get to all the regular tools that you would normally have by right-clicking on things. It's good for relatively complex geometries, but it's a little bit less user-friendly than a lot of actual dedicated CAD programs. So for truly complex geometry, it's generally better to do it elsewhere and then import it. So with the revolve, you have some options how you want to rotate it. But again, this is best served probably just by messing around with it a little bit and figuring out, hey, how does this work? What are the types of things I can do? For the moment, we're just going to extrude this, sure, blindly 1/10 of a meter. Excuse me. There is one type of option you want to pay attention to. If it says merge, imprint, or none anywhere, merge is going to take, if this touches any other solid, it's going to take all of them and make them one solid piece. None is going to say, I don't care if this touches another solid or not. This is going to remain its own thing. And imprint is going to say, okay, if this touches another solid, I'm not going to make them part of the same thing. I'm not going to merge them together, but I'm going to draw a line where these two solids touch. Imprint can be very important if you're dealing with multiple different fluid domains or regions. We'll get to talk a little bit about that later. That's a little bit more of an advanced thing. It can be especially useful if you're talking about heat transfer and you need to model the solid or like a solid block of material and the air around it, because you need the surfaces that connect those two to be cleanly defined. But usually merge is okay. Sometimes none, but usually merge works just fine. So if we click OK, we have our very shoddy interpretation of an airfoil. Now, if we want to turn this into a part, because we can't actually do anything with this now. It's a 3D CAD thing, but to do anything really within STAR-CCM Plus, we need something here on the parts level. So we're going to right-click this. Actually, no, we're going to remember we're in this 3D CAD tab. So we're going to go ahead and hit Update 3D CAD just to make sure it's up to date. Hit Close 3D CAD. And notice that there's a caret on the 3D CAD models now. And we can see that our model exists here underneath it. So again, things have different levels. So under Geometry, we have a folder for 3D CAD. Under the folder for 3D CAD, we have our 3D CAD model. Within our 3D CAD model, we have however many bodies we had, in this case, just one, and any design parameters we used. We didn't use any design parameters, so there aren't any, but if we had any, they would show up under this folder. So if we want to turn this 3D CAD into a part, which we do need to do anything with it, we need to right click and say New Geometry Part. So you have a couple of options here. Usually the defaults are fine in most applications, or sorry, I don't want to say the defaults are fine in most applications. The defaults are the most general purpose defaults they can think of for the most part. If it's possible to make a default that will work for most applications, that's what they set as the default. So CAD part with 3D CAD association means that if we go back and update that 3D CAD, it will update the part that we're about to create. Create part contacts from coincident entities, excuse me, means that it'll just make a note if two blocks are touching. It'll separate out the faces that are touching and know that those are touching and the others aren't. And this coincidence tolerance is if you have those two blocks, how close do they need to be before they're considered touching? In this case, it's like 1/100th of a millimeter. Hold on just a second here. I need to send a message really, really fast. Mark feature edges, sharp cat edges is fine. 30 degrees is generally fine default, and the tessellation of medium also works just fine for most applications. There are some reasons to change these, but these work for the vast majority of applications. So we can click OK, and we can see that suddenly there's a thing under the parts folder. Let's look at that. So it shows body 1, which it created from our 3D CAD model 1. So let's see here. Parts is where we're going to deal with most things. We can get things into parts by importing them from 3D CAD. We can also import from exterior geometry. So if we go to File, Import, and Import Surface Mesh, we can import files from elsewhere. So let me see here. Perfect. This will do just fine. I think those are STLs, STPs. I'm just looking for a file. Specifically, the type of file we're generally going to want to deal with is going to be a .x_t. It will recognize other files, but it doesn't like to play with them very nicely. It can work with them, but x_t, otherwise known as a parasolid file, is pretty universal. Like most programs can output them, Star will happily take them, and they work pretty darn well. So let's go ahead and just, for the sake of argument, open up this NACA 4412 airfoil. And we get some options for importing this. Some of them are the same. Sharp cat edges, 30-degree angle will be marked. Create part contacts, merge parts by name. Create one part surface per part is generally an advisable thing. But depending what you're doing, if you're doing something simple, you can maybe leave that unchecked. The issue is for anything complex, this is going to give you so many surfaces, it's going to be pretty impossible to deal with. So I'm going to leave this unchecked because the airfoil is probably pretty simple. But in general, you might want to check that to avoid a list that's a mile long down the left-hand side. The rest of this is probably fine as default for most applications. The descriptions are pretty self-explanatory. The one that you also want to think about is these import options. Open geometry scene after import. If you don't have a geometry scene, like we currently don't, it's fine to leave this checked, but generally you're going to want to uncheck this so you don't make a half dozen different scenes when you keep on importing geometry. So click OK, and we can see that it opened a geometry scene. Down here under scenes, there's a geometry scene. Talk more about those later. And we can see our airfoil, and it's got a little bit of an issue over here. Oh no, this isn't an issue. This is the thing we created earlier. So we've got our airfoil, well, wing, really. And we've got that other part we made in 3D CAD. And notice that they're on top of each other a little bit. They occupy some of the same space. So again, to recap briefly, if you want to import geometry from an external software, generally file, import, and import surface mesh will pull in something to the parts level that you've defined in an exterior file. And it will name the thing the same thing as the file that you just had. And it will show up here. If you don't have one of these geometry scenes, you can create a new one. If you want to right-click on scenes, new scene, geometry, it will create a new geometry scene showing all relevant geometry in the simulation. So I can hit new geometry scene, and we get one that looks the exact same. So if you lose your geometry scene, you can always create a new one. You can always delete old ones, so I'm just going to delete geometry scene 2. Just click on it, hit the delete key, works, or right click and delete. We can create new parts directly on the part level, basic parts, by being able to create either blocks, cones, cylinders, or spheres. So blocks are a little bit limited. You do have, if you have a geometry scene open, you'll get these pull handles you can use to move the edges of the block around, but notice that they're all orthogonal to the coordinate system, right? That's the limitation. You can create whatever size block you want, X, Y, Z, whatever origin you want. But the faces are always going to be orthogonal to the coordinate system when you create them. You can also type in values, so let's do like -1, negative. Let's just do a literal cube. Keep things easy. 1, 1, 1. Okay, we got a cube 1 meter to a side. Located at the origin, it extends from -1, -1, -1 at one corner to +1, +1, +1 at the other. If you have different coordinate systems, you can select them, but that's a kind of more advanced thing. We're going to probably not deal with that this semester. So we can go ahead and click create. And notice the tool doesn't close. We can create more random rectangular shapes in rapid succession by changing these limits and hitting create again. So now we have 2 blocks, a cube and this other large one. We can also create cones, which are defined as effectively 2 circles. So you have 2 points. So in this case, let's go with a line that is 2 points that are separated by 5 meters on the x-axis. The first point is at the origin. Actually, let's move this over a little bit. It's going to be a couple meters behind the origin, actually. So the first point is here at 0, 0, -2. And the second point is over here, where this red dot is, at 5, 0, -1. And you define the start and end radius. So right now this has a circle that is normal to that line connecting those 2 points with radius 1. We can set this to radius 5 centimeters, and you can see that it got a lot smaller. It's not 0. We could make it 0, make it pointed. Or we can make it something small, or we can make it something large. And then we can also change the radius at the back. And like before, you can drag this point around graphically if you so choose. It's a little bit less precise, obviously. I prefer to type in exact numbers in most applications because you get exactly the number you're after. That shouldn't be a negative value. Radius should not be negative. If we type in a negative value, that's going to do funny things like this. This is not good. Don't do that. Positive radius only. So that's the cone. The cylinder is something very similar. The only difference is, in addition to, or instead of setting a radius at the start and at the end, you just have a constant radius. Cylinder after all. So again, we can say like, let's do 0, 10, 0. This is well above the airfoil. We'll do 5, 10, 0. And to flip through these rapidly, I'm just hitting tab repeatedly until it highlights the field I'm after. So we can change the radius here, and it'll change just the radius of the entire thing, right? It's not changing one end or the other, it's the radius of the entire thing. You can think of a cylinder, depending which way your brain wants to look at this, you can think of a cylinder as simply a cone where the start and end radius is the same. Or you can think of a cone as a cylinder, except one of the radiuses at one end is bigger or smaller than the other one. So let's go ahead and click create really fast there. So we have a couple of blocks. We have our cone, we have our cylinder, and last but not least, we can define a sphere, which is the simplest of all of them. Actually, doesn't want to let me move this very far because it thinks it's bound to that airfoil or the bounding box of that airfoil for some reason. I'm not worried too much about it, but let's put this well below our airfoil here. So we have our sphere and we can set the radius to whatever we want. We can make it a 5-meter radius sphere. Or we can make it a 5-inch radius sphere. Or even smaller, 5-millimeter radius sphere, which is really hard to see on this scale. So if you already assigned a unit and then you just type in a number, because I just typed in 5 millimeters, right? If I just type in 1, enter, it'll still use whatever unit it had left. So if I type in 1, it says 1 millimeter. If I want to change this to meters again, I have to type in m for meter and get it back to 1 meter. So we have all these different shapes. But notice that they highlight in this scene, but they don't actually show up. Well, for the moment, the simple thing to do is go ahead and create a new geometry scene, and you'll see they all show up. We'll get into the scenes a little bit later to talk about, but the scenes do not automatically update what they include. They'll only ever include things that are included when they are created, or things that you add to them. So we've got a whole bunch of random shapes kicking around. And what do we do with these? How do we manipulate them? And you can manipulate anything on the parts level. To be clear, it doesn't have to be one of these blocks that we just made. We can manipulate body 1. We can manipulate this airfoil. But the way we do these manipulations is with operations. Now, there's a lot of things floating around in operations. There are only a handful that we're going to need for the moment, but mostly it's pretty self-explanatory. Mesh we're not going to need for the moment. Boolean we're going to need, and we will need a couple of things from surface preparation. So let's go ahead and mention one of the most important things about operations is that the order matters. Up here, it doesn't matter what order these are in. As a matter of fact, I think I just may have made a copy of that. Or not. But order does not matter for these parts. Operations order matters. So, if we want to, let's say, move a thing, well, that's a transform. We can select the thing or things, plural, we can select more than one that we want to move. Let's say we want to move everything over 5 meters. Well, how do we do this? Well, we select everything. And notice we have some properties down here that we can mess with. And we need to open up this transform and say, hey, I want to translate, or I want to rotate, or I want to scale or reflect. And then a couple more advanced ones. So let's just say I want to translate. Again, we have a little bit of a tree. It's growing. So we have a transform operation that has one transform as part of it, and this is told to translate this thing. We are going to tell it under properties to translate -5 meters in the x direction. This is one of the reasons this property window is so useful, is because you can just change numbers directly from here. You could also right click and hit edit. That works too. It'll bring up a menu where it'll tell you, hey, I'm transforming this in what direction, by how much. So you can click on any of these numbers, and you don't have to type it in as shown here. You can just type in 3 numbers with spaces in between them. So you can type in 0 space 0 space 10, and it'll convert that to this vector format. Or let's say 100 space 0 space 0 space inches. And it'll do that too. So this will translate everything that we've selected by 100 inches in the x direction. So let's just hit execute, and they all moved over. We can say -300. Hit execute, and they all moved over the other way. We can also add more transformations if we want. We can tell it, after translating, go ahead and rotate about some origin. Let's do -400 0 space 0 inches. Rotate about the z-axis, so 0 space 0 space 1 is the z-axis. And let's do 180 degrees. And it all flipped over. All right, the sphere that was at the bottom is no longer at the bottom. And we can also just tell it, hey, turn off this transformation or turn it on if we just want to temporarily disable it by checking or unchecking that box. So let's disable it really fast and run this again. And we can see that all it did was the translate. It didn't do the rotate. We turn the rotate back on. We can see that it gets a little warning triangle saying, hey, you changed something about this, or you changed something that affects this. And hit execute again, and we can see it does the rotate. You can also scale. You can make things larger or smaller. So let's do 0.5. And if we just want to do a uniform factor, we can just hit 0.5, and it'll apply it equally to all directions. So it just scaled everything about the origin by 50%. We could also reflect about whatever vector we want. Let's see here. So if we want to reflect about the origin and the YZ plane, we can just plug in the origin as the origin, and the normal to the YZ plane is going to be X. So we hit execute, and it flips it across that plane. We can also disable that, hit execute, etc. So this is how we move things. So whether you rotate, translate, or a combination thereof, and you can do more than one of these. You don't have to have just one of them. You can create another transform that just moves that block, for example. So let's move just that block by, I don't know, 2 meters in X. Execute. And just move that block 2 meters in the X direction. 4 space 0 space 0. Execute. So you can do things that are mostly just limited by your creativity and how many steps you want to do. You can do a lot with transforms and basic shapes. We can also transform the shapes that we created. You saw we were moving this airfoil around. We actually flipped our airfoil upside down, as it turned out. We were transforming everything earlier. Or you can just transform one thing. Doesn't matter. You can also pattern things. So let's take our first block and let's create a pattern where they're spaced 1 meter apart in the x direction, and there will be 4 of them. And then in the y direction, also 1 meter. Let's actually do 2 meters apart. 2 meters apart, and there will also be 4 of them. Let's do 3 of them, actually. And execute. Now, they didn't show up, but if we create a new geometry scene, we have a 4x3 array of cubes. Could also do this same thing with our sphere. We could create, let's see here. So right now this is about the z-axis, centered at the origin. We can create a even distribution of 6 of these, let's say. Execute. Again, they didn't show up. Let's create a new scene. And we have 6 spheres evenly centered about the origin in the XY point. Now, we have effectively a whole bunch of random shapes just kicking around. I'm going to delete this linear pattern. I'm going to delete the circular pattern. And delete all of the spheres that these and blocks that these patterns created. We don't need them. However, what I'd like to do is talk about a couple of more operations before I wrap up this video, I think. And these are the Boolean operations. These are how you combine things. Translate is moving things. Patterns are creating new things. And these other things do other fancy things. Boolean interacts things. So let's do a Boolean unite really quickly here. And what this says is I'm going to take these parts and I'm going to combine them. Okay, well let's click on our block 2 and our cone. These two things right here. And we're going to say, well, this is unite operation. So what we're saying is, if we click OK, it will create a new part called a unite. And if we hit right-click and execute and tell it to actually do this operation, suddenly, if we select this unite, it's composed of everything that was that cone and that block put together. Now, the cone and the block are still there separately, but we also have a new part that is those two parts combined, united. Unites are pretty simple. You can select however much you want and hit unite. And I don't even believe that they need to be touching, so let's try that really quick here. If we select block 1 and block 2, click OK and execute, we can see that this unite is one part. Click on just the unite and it highlights both blocks. So they don't even have to be touching for this to work. Unite's pretty simple. It will create a new part that is the combination of all the parts that you input into it. Subtract is the other one that we tend to use a lot, which is the reverse. So you select every part that you want to involve in the subtract. So let's just say block 2 and our airfoil, for example. This is everything involved in the subtract. The thing you want to cut away from and the thing you want to use to cut it. Or the things, plural, that you want to use to cut it. You know what? Let's go ahead and select multiple things just to drive this point home. So we're selecting our big block here, our cone, and our wing. Now, how do you tell it which one you want to cut stuff away from? Well, that's the target part. What do you want to remove material from? In this case, we want to remove material from, let's say, this block. Click OK and execute. And again, we see that there's a new subtract part. And this part, it's a little bit hard to see, but it actually has a couple of large holes in it. One where this cone was, for darn sure, and you can also see there's a hole in it where that airfoil touches it, or that wing touches it. So the subtract cut away this wing and this cone from this block. And now we have a very interesting shape as a result. There's a couple of other operations that aren't going to be super important right now. You can mess around with them if you'd like. But unite and subtract are the big ones. So, just to kind of, I encourage everyone to spend a little bit of time messing around with operations, just moving shapes around in random ways, and seeing what happens. But just to recap, we have several different tools at our disposal here. We have 3D CAD models, where we can edit this one, and we can do complicated things with sketches, extrudes, revolves, pretty much all the features normally associated with a fully featured 3D CAD tool of any sort. SolidWorks, Creo, Inventor, etc. Oh, and if you see any of these yellow triangles, if you right click and hit update, it will attempt to run whatever it did again, just to make sure that it's the most up-to-date thing possible. You don't need to do it, but if you see the little yellow triangle, it thinks that whatever you did could have changed that thing with the yellow triangle. So if I edit this 3D CAD model or click update, you'll notice that a bunch of things turn yellow because it thinks that whatever I just did to the 3D CAD model could have affected these things. It didn't. I didn't do anything, but it could have. So you can right click and hit execute, right click and hit update. And it'll basically do the thing again to make sure that it's the most up-to-date possible. But we have 3D CAD to do fancy things with sketches and extrudes and revolves and other 3D CAD type things. We have the ability to create basic shapes. New shape part, block, cone, cylinder, sphere. You can also do composite parts to combine things into one part. We tend to stick with the shaped parts and use Boolean in order to combine things, at least in my personal preference. We have the ability to create operations to transform things, whether this is a translation, a rotate, a scaling, a reflection, many different things. And you can do the same operation multiple times in different ways, and these all have properties that define how they work. How much are you transforming a thing? How much are you rotating a thing? Etc. With respect to what point or surface are we translating or rotating, etc. That's a mesh. We can create linear patterns, circular patterns, and do other stuff that we haven't talked about yet. We can unite parts, creating one part from multiple parts. We can subtract parts, cutting parts away from others. And it shouldn't take a great stretch of the imagination to realize that these tools, in combined creatively, can do a huge amount of things. Does it make sense? That depends. Again, you can either, from a highly conceptual standpoint, you can build a new simulation from scratch in STAR-CCM Plus, or you can build it or have it built somewhere else and pull it into STAR-CCM Plus. Either way is perfectly valid. We will tend to mix and match a little bit. We will generally have sort of the very simple geometry we might just create. But for anything more complicated, like a organically curved airfoil, for example, I'm probably going to create an exterior file that I give to everyone, and you'll be able to import it, and then you'll need to create an air volume around that airfoil. Um, Actually, that's a good point. So if we want to create a air volume for our airfoil here, I'm going to go ahead and delete pretty much everything here so we have a nice clean workspace, since most of the stuff doesn't actually matter. Until we're left with just our airfoil. So let's say we wanted to model flow around this. Let's think of it just as an airfoil for the moment and not a wing. So we need to create something that defines the amount of air. So we can create a block of air that is going to encompass this wing. So let's make this pretty big. So we have a whole bunch of air above and below this thing. Notice it doesn't extend beyond it on either side. It just extends in front, behind, above, and below. And we're going to create this block. So we have a block that represents the total enclosed volume of the air, and we have an airfoil stuck inside of it. The thing is, there is no air where our airfoil exists, so we need to subtract our airfoil from our block. So we select both our airfoil and our block, and then we say we are targeting our block. Okay. And right click and hit execute on the subtract, and we see we have a new subtract part. So if I do new geometry scene here, we can see that we have, well, actually a couple different blocks on top of each other. So if we want to verify, and don't worry too much about following along with this for the moment, I just want to demonstrate that we do indeed have a block. Where is it? That we do indeed have a block that is just a block with the airfoil cut out of it. So we have this block, and it does indeed have an airfoil cut out of the middle of it. That would be one of the simpler types of simulations, but we successfully created a block with a hole in it that is the shape of our airfoil. So if we wanted to model the air around this airfoil, that would be represented by this subtract block. It's the air above the airfoil, below the airfoil, in front of it, behind it. But importantly, there is no air where the airfoil exists. This is a basic way to set up a simulation. And the same methodology applies for most things. You create the thing, whether it be an airfoil, a wing, a plane, a boat, what have you. You model the actual thing you're interested in, and then you create a enclosure for fluid around it. And then you cut away the body of interest, again, boat, plane, airfoil, whatever, away from that fluid. So you have your fluid, and then you have a hole in the middle of the fluid that's shaped like the thing you're interested in. That's kind of a general way to approach modeling something to prepare it for CFD. Now, when you're dealing with basic shapes, it's hard to run into too many problems, but you should keep in mind those do's and don'ts regarding geometry. right? You don't want tangent circles. You don't want sharp interior corners. You don't want a whole bunch of different things. You don't want surfaces that have very small gaps in between them. Um, and you need to keep that in mind. It's fairly unlikely you're accidentally going to do that, but it is possible to accidentally do that when you're creating geometry from scratch inside of STAR-CCM+.
I didn't get that. Could you?
So we are going to go ahead and leave it there, and I'm going to post this up, and hopefully that'll tell you what types of tools you have available. And I realize this is probably a little bit like drinking information out of a fire hose. So you might want to watch the video a couple times and then just open up a simulation and mess around with the tools that you have available. Try and combine things in weird and interesting ways. Maybe try and make some basic combination of shapes. Um, Learn a little bit by doing. This is what tools are available. To know really how they work, to actually know how they work, you usually need to give it a go yourself. But we will talk about that more in the upcoming class.